In today's chemistry riddle, we have the starting material and we have three different products, and it's your task to figure out how can I selectively achieve the transformation either to this product or to this product or to the third product. Please try to figure it out by yourself first, and then afterwards listen to the explanation that I will offer. So let's have a look. We have three functionalities here, three carbonyl functionalities. Here an aldehyde, it has the highest reactivity of those three carbonyls, then the ketone, then the ester. In all three cases we have it to do with a reduction. Here in this product exclusively the ester has reacted. Here all three functionalities have been reduced, and here the ester remained unreacted and the reduction took place at the ketone and at the aldehyde. So we have a selectivity problem. Well, what reagents do we usually use in the lab, at least in the lab, for reduction complex hydrides? In industry, one would prefer the catalytic hydrogenation. Well, reduction here, for reducing all three functional groups, even the ester functionality, we need lithium aluminum hydride. So lithium aluminum hydride is the reducing agent of choice to achieve the full reduction of that system. Here, the least reactive functional groups remained unchanged. So we are in need of a complex hydride with lower reactivity compared to the lithium aluminum hydride. This is lithium orohydride. This will work just fine. But here in this case we need the opposite selectivity. Only the ester functionality should react. How can we achieve that? Well, we are in need of protecting groups, and the preferred protecting groups for these carbonyls are acetals. So, in this case, best will work cyclic acetals with ethylene glycol. So, and eliminating water, forming cyclic acetals here and cyclic acetals there, while under these reaction conditions also a transesterification will take place. So the ethoxy group is exchanged to an hydroxyethyl oxy group there. But this doesn't change the outcome of the reaction. Since this is protected, this will be protected, nothing happens here. And with, again, lithium aluminum hydride, also the transformed ester will be reduced to the hydroxy methyl group. And of course, in the last step, we have to hydrolyze the acetal functionalities. Simply under acidic conditions in water we will get to this molecule. Thanks for listening.